will get the one physical server. And if you wanted to set up a 10 server, then you'll get a 10 physical server. So at that time, what used to happen? So basically, yeah, if you want to install MySQL, you get the one server, MongoDB one server, Redis one server, Nginx you get n number of server, Apache you get one number. So basically, 15 years before, we were in a physical era, physical server era, where you used to have a servers and used to get these servers, physical servers, and each of these physical servers used to have a CPU, RAM, hard disk, operating system, and used to pay for the what do you say, operating system costs also, right? So that was the era which we were living 10 to 15 years before. Okay, so now at that time the utilization of the internet was very less. When you look at the uses of the cloud computing, like internet and storing the files or accessing the things, it was very less. I remember we were using the Yahoo and Hotmail, and few hundred MB of the capacity of the each mail used to get it, right? And nothing more than that. So now so with this introduction of all, with the cloud computing, popularity of the internet, and it's become reachable by everyone, we started using cloud based services, internet based services a lot. So here what I'm trying to say, tell you right now, it's like 15 years before, we were in the physical servers era. When we wanted to set up a servers, we used to buy the physical servers, boxes, Dell boxes or IBM boxes. And when you want to set up a physical servers, basically you set it up like, okay, let's go for this much of RAM, this much of CPU, this much of hard disk, and this operating system, and you used to pay for that, and slowly you used to configure those. So that was a kind of physical era. Look at the wastage here. Okay, look at the wastage. So now also, if you look at your laptop which you are using right now, how much resources you are using, how much resources, maybe 10%, 15%. So that means all together you have, let's say, 5 GB of RAM or 10 GB of RAM, and out of which you are using only 10 to 15% of the resources. So in a simple way, in a simple word, 85% of the resources is getting wasted. Okay, that's just visualize that. In your laptop right now, 85% of your CPU, RAM, storage, you are wasting. Okay, so that's the kind of waste what you have. Now, if you look at the same wastage to the data center perspective, okay, data centers where you have hundreds of physical servers, not one, hundreds of physical servers. So the wastage was huge. But one of the challenges which was experienced by the organizations, where like we had a explosion in the internet users, but no one wants to pay for the services. Have you ever paid for the Google? Have you ever paid for the Yahoo email? Have you ever paid for the Gmail? Have you ever paid for the watching the videos on YouTube? Have you ever paid for the using the comparing the tickets on yatra.com? Have you ever paid for the getting the statement from the ICICIbank.com? Have you ever paid for those services? Have you ever paid for the WhatsApp? Right? So you're not paying for the services. So the challenge for the organization, what they have got it is like they want to serve all the applications, okay, that is there, and that too also free of cost. So they have to reduce the deployment cost, they have to reduce the data center cost. Like they should be able to serve more application by utilizing lesser CPU, lesser RAM, lesser storage, no operating system cost. But that is also like a far away. So they wanted to utilize that kind of things. They want to reduce their cost. Okay, so now we were in the physical servers era, and suddenly we got the virtualization era with the help of the VMware. So VMware, what they introduced the virtualization era, and in which now if you have a 10 servers requirement for the organization, basically you do not set up the 10 servers, you set up only one physical servers. Okay, and in one physical servers you set up 10 virtual machines. Okay, so that is the thing what we do. We have a physical servers, In the physical servers, we set up the virtual machines. Now utilization has optimized. So this is the, if you look at this image here, you can see that this, you have a hardware, on top of that you have a hypervisor. This hypervisor is nothing but a KVM, VMware and Zen, and on each of the hypervisor you have a virtual machines, and inside the virtual machines you have your application which is running. So this is the era which is, we call it virtualization era. Okay, so now what basically this has done, this basically saved us the wastage of the resources. So in the physical servers era, our wastage was almost 90% or 85%. That got reduced to the drastic level. That means we are now in the virtualization era, we are able to optimize the resources utilization to the maximum level. Okay, so that is what has happened. So you can see that the you have a more CPU, more RAM, more storage, no problem, you can create more VMs, and then wastage can be reduced. So rather than buying the physical servers, you get the VMs. So that is what it has happened, and I believe everyone has worked with the virtual machines, right, using VMware, VirtualBox, Zen, vSphere, and so many hypervisors are there in the market, right? So this was the kind of virtualization era. Now we could reduce the wastage, but the problem what we have right now is like we are the people. Now remember, we had a Gmail which got started with a 500 MB many years before, let's say 12 to 15 years before. Now we are getting 15 GB. Look at that, from 500 MB to 15 GB. I remember when I was using my laptop, personal desktop, I was very much happy with the 40 GB of hard disk configuration, let's say 13 years before. But now we talk about in TB, not GB actually. So how much storage you have? At least a 1 TB you have, or maybe 2 TB you have. So look at the utilization of the, resources. How many times you have deleted the emails? You are getting millions of emails in a year, thousands of emails in a month. How much emails you deleted? Yeah, you never try to delete any emails. So millions of videos is getting uploaded to YouTube, millions of images is getting uploaded to facebook.com, thousands of transaction is happening every day on the ICICIbank.com or HDFCbank.com, Atra.com. They're booking millions of tickets in a day. So how come this is happening, right? So we have a growth, huge growth in terms of using the internet-based services, cloud-based services. Okay, so that because of this need of the growing all the services in the cloud, all the organization who's offering the cloud-based application or internet-based application are getting impacted, because you are not paying for those services, you are paying nothing for those services, so they have to reduce the cost of it. Yes, so you do not pay for the google.com, you do not pay for the searches, you do not pay for the YouTube, you do not pay for the browsing the catalog on amazon.com. They get paid only if you buy it, right? You do not get paid for the comparing the tickets on yatra.com, right? You do not get paid for doing the transactions on ICICbank.com or getting the count statement and all, right? So many things which you are not paying, you are paying only when you subscribe for the services during the specified time period. Remember, let me remind you, when we were using the operating system, we used to buy the CDs. And we used to pay upfront. We used to pay upfront for the Microsoft operating system, Office. Maybe if you want to play some games, you used to buy a subscription, CD based. Any other software, if you want to buy it, you used to buy through the CDs, and you have to pay much in advance, no matter whether you use it or you use those software or not. The organization will not care about that. But right now, all the payments, all the transactions of the services which is based on the internet has become a subscription based. That means you have a tenure in which you want to use those services, and you want to pay for them only for that tenure. So here organizations are getting impacted a lot, because earlier they used to get the payment upfront, but now they are getting a payment only if you subscribe for the services. And just because of this nature of the consumptions of the applications on the cloud, organization has got the challenge, like they have to reduce the cost drastically. They cannot afford to have everything free on the same model what they were doing. But the problem here is we as a consumer would not like to pay for it. You would not like to pay for the Google. You would not like to pay for the consuming the streaming the videos on the YouTube. You would not like to pay for the email services. So what they have to do, they have to again reduce the cost, because they have to do so they can host more and more applications, they can host more and more services, but utilizing in the lesser cost. So what is the solution? So now coming back to the point, we are living in the virtualization era. You have a different kind of cloud model. So you have a public cloud, private cloud. In terms of public cloud, you have AWS, Azure, Google Cloud. In terms of private cloud, you have a VMware, Zen, ESX, and so many things. You have a hybrid cloud. So there's so many cloud model, and you have all the application which you're using. So what has happened? Cloud virtualization has helped to maximize the utilization of your hardware resources. But just because of the very exponential growth in the internet and cloud-based services, still there is a lots of scope to reduce the deployment cost for the applications. Okay, and virtualization technology is not helping us. So now what to do now? So virtualization technology is very efficient. It's trying to avoid the wastage of the infrastructure. But if you still want to upgrade your infrastructure, or maybe you want to migrate from the virtualization to something else where you can host more application using the same CPU, same RAM, same infrastructure, what can it be done? So look at the virtualization model. This is the picture in which you have a virtualization model. Here you have a base hardware layer. On the top of it you have a hypervisor layer, and then top of that you have a virtual machines. Remember, each virtual machines also has a very heavy operating system. Let me recall the things which you already know. Each operating system is also consuming lots of CPU, lots of RAM, and lots of storage. And on top of it, you are paying the subscription charges. So in a simple way, if you want to host 10 apps, yes, you can very well use the virtualization technology. But for the 10 apps, to hosting the 10 apps in the virtualization technology, you have to have a 10 operating system. That's the question. Like, why do we have a repetitive layer of the operating system in the same base machine to host the multiple apps? Is it really needed? Is it really OS is adding any business value? Is there any possibility? Is there any possibility we can run the app without the duplicating the multiple level of operating system? Is there any way? So people have started considering into that fact, like, okay, can we avoid the multiple layer of the operating system? Instead of going to multiple layer of the operating system, we should get only one layer of the operating system and should be able to run as many apps you wanted. Because here, if you see, if you have X number of CPU, RAM, and storage, OS is considerably consuming lots of CPU, lots of RAM, and lots of storage. So can be avoided? Yes, that can be avoided. What we can do, we can replace the virtual machines with the heavy operating system with the containers. Again, I'm reminding you, we can do that, because the problem what we have right now, we have exponential growth in the internet and cloud-based services. So we have to reduce the cost, and same time host more application in the same existing infrastructure. Okay, so now what we are trying to do here, is it possible like we can replace the virtualization model? So we can replace the virtualization and multiple layer of the operating system to the something else where we can host the more apps with the same infrastructure. Yes, so that can be done through the containers. So containers are more lightweight than virtual machines. In a simple way, containers consume less CPU, less RAM, less storage, and no license cost to run the app comparing to the virtual machines. So now you must be wondering, what is a containers? Okay, what is a containers? We'll explore that what is a containers and how it works. But before that, I would like to ask you, do you have any questions so far? So now we have discussed the case scenarios, like why do we need to move on to learning the containers technology instead of from the virtualizations. So we were in the physical server era, we moved to the virtualization era, now we are moving towards the containerization era. And did you understand what is the need of moving from the virtualization era to containerization era? Is that clear for everyone?
Yes.
Cool. So now you must be wondering, okay, cool. So you must be wondering how this containers works, how this container works, because we say containers are more lightweight than virtual machines. In a simple word, if I say you can run more apps using the container than the virtual machine using the same infrastructure. The superb, right? But you need to understand how container works. Let's look at this image here. Here, what you have a physical machine, physical hardware layer. On top of it, you have a user operating system, and top of it, you have a user space. Let me recall, an operating system can have multiple user space. For example, in Windows, my user ID is Rajesh, and I have got the user space which is C users Rajesh. If you're talking about in Linux, you will get something like /home Rajesh. So in one operating system, you can create as many users you wanted. Interesting thing is, each user to have their own user space which is not accessible by other users. Only root can access it everything, but not any other users. Is that clear for everyone? This is the model which we have in the operating system. Okay, and then top of the user space, you can run app until there is a no port conflict. Each user can run their own app. For example, I have one machine, I have a 5 user 1 can run the app HTTPD on the port 80, user 2 can run HTTPD2 on port 8090, and user 3 also can do the things by changing the port. Is that possible? Everyone is agreeing on that?
Yes, it's possible.
Wonderful. So now this is the model what we have in operating system. So you have operating system, you have a user space, you have an application. So in each user space, you have an application. But here is the problem. Here is the problem. Here in this operating system, you can have a multiple user space. Each user space can host their own applications. So can we replace this user space? Again, I'm repeating this line. Can we replace this user space with something like a containers? Look at this here. Here we have user space. We have 4 users, 4 containers. Can we replace? And each containers will have an app. So is there any possibility? Yes, there's a possibility, because user space is a isolated environment. Again, I'm reminding you, user space, each user space is isolated environment where each users can run their own app and other user will not be able to access it. but there's a problem. Yes, we replace the user space with the containers and the app. Yes, you want to know what is a container? We'll discuss again, but let's understand. User space, containers, user space, containers. Now, what is a containers? Here we got the challenge here. If you look at this is the again virtualization era. Here you have a multiple level of operating system. In the virtualization era, if you see that, here you have a multiple level of operating system, and each operating system what you have, each operating system you have, just a second. Let me put it in this because slides is missing. So each operating system you have, let's understand this. Each operating system you have network, so their own network, own mounts, own permission, okay, and own storage. This is the one, right? So this is the virtualization era, okay? So if you see that here, you have their own network, own mounts, own permissions, own file systems, and own process maps. Process map is very important. Process map is very important. Own process map. Now, map. Okay, now if you look at this here, in this model here, if you look at this, I said, can we convert the user space to the containers? That is very much possible, but each container need to have their own mounts, their own network, their own process map, and their own permissions. That is the challenge here. Yes, we can launch we can convert the user space to the container. That is wonderful, and inside the container we can run the app. But how can we have each container their own network, their own storage, their own process map, and their own permissions? How it can be possible? Because each app need their own app network, their own mounts, and their own permissions, and their own process map. That is not possible, because if you look at this model, every users will get the same IP address, every users will get the same mounts, every users will get the same sort of permissions set, and the process map will be also derived from the same. So how can we make it possible? So here what we are trying to do, here we are trying to, if you look at this here we are trying to avoid the multiple layer of operating system. So instead of on hypervisor, you have a virtual machines. Each virtual machine has an operating system. Rather than having this operating system multiple times, we are replacing with the multiple user space. Inside the user space, you are running the application, and that is being called as a container. But the challenge what you have, we are not able to get the own networking, mounts, process map, and permissions. How it can be possible? So we'll have to find out the way. Okay, now look at this here, this picture. Here you have a hardware layer. On top of it, you have a Linux kernel. Okay, again I'm reminding you, this is the hardware layer, and top of that you have a Linux kernel. Kernel is the smallest operating system. We are the human beings, we need a very heavy operating system, but for running the system, from the running the app, you don't need the heavy operating system. It can run on this very tiny operating system also, that is called kernel. So if you look at this here, yes, containers you can run on the kernel. You don't need a very heavyweight operating system, but containers need, and each containers will have their own app, and also container needs their own network, their own mount, their own process map, their own permission. So how can it be possible, that we'll come to later, but containers consume less CPU, less RAM and disk resources than virtual machines. So it's very clear, like, okay, if you want to host, let's say you have one hardware, physical servers, and if you want to host, if you are using the virtualization technology, you can host 10 virtual app, sorry, you can host 10 virtual machine, and in a simple way 10 application. If you go with the containerization technology, you can host probably 18 or 20 or 30 application, because you are saving huge amount of CPU, RAM and storage, which was being spent on the operating system. So here we have a same base of operating system. Okay, so now you must be having a question in your mind, how these containers will get their each container, because each container is nothing but an isolated user space, and each container is nothing but having their own IP, own app. How this each container will get isolated network mount, so they should not conflict with each other. Because if you install in one user, let's say in one operating system, you have a two user 1 and user 2. If you are running HTTPD server on 8080 port, other user will not be able to run it on the same port, but here we want to run it on the same port. So how could it be possible? How could it be the networking will be separated, right? So we need to discuss this one. Let's look at this here. So we have to understand how container works. If you look at this model here, you have physical machine on top of that operating system, which is nothing but a kernel, minimal kernel, and top of that you have user space. You can have install multiple app in one user space, or you can have multiple users and multiple app. Look at this here. Here you can have multiple app installed by one user, and each app we must have the port number difference. That is the things. Each app must be, because else you will not be able to run it, because the networks are same. Now here, if you have a multiple users and each user is also running the multiple app, same app multiple times, they should be having their own network. Also they should be having their own mounts. How it would be possible? So basically what is happening right now in the containers world, we have a mounts, and we have a process map, and we have a network that need to be duplicated multiple times. Okay, so look at this here. First, this image is showing, this is the mounts which you can see. So here, this mount is duplicated by 3 times. Okay, 3 times, and each container will get their own mounts duplicated from the host machine. That is also happening with the process map. Here you have a top process map which got duplicated to the each containers again, and here you have a network. Here you have a network, and that also get duplicated to 3 times. So you must be wondering, how come this container is duplicating the operating system mounts, network and process map. That is being done with the help of kernel. So kernel is this capability was there since the ages of the computer science, computing era. So each kernel, you have a PID, you have a net, you have a MNT, and you have a user space. Yes, you have many other namespace, but these are the important namespaces which you have, which will be exploited by some software. So PID will be duplicated to n number of time for the process map. Net namespace will be duplicated virtually to n number of time for the n number of containers by some technology, MNT namespace will be duplicated virtually by n number of times for n number of containers, and same goes with the user namespace also. So these namespace will be duplicated virtually by n number of times. But the question is, what about the process? So each containers required some CPU, some less CPU, and other containers required some more CPU. So how can you control it? Yes, you can duplicate the process map, you can duplicate the network, you can duplicate the mounts, and you can duplicate the user space. But how can you assign a CPU and RAM allocation to the multiple containers? And that can be done by the C groups. C groups again is inbuilt with the kernel that will help us to assign the CPU and RAM, required CPU and RAM to the each containers. So now we could see that here. What we are trying to do, let me recall this discussion. Here we have a multiple user space, but we can have the multiple user space, but we need a isolation. Yes, we need there in each user space we need a isolation, greater amount of isolation in terms of network, in terms of process map, in terms of mounts and stuff like that. So who can create isolation? Containers. So we need to understand how container works. So containers is nothing but a specialized isolated environment in which the process map, network, mounts is getting duplicated, and these with the help of the kernel namespaces, and C groups is also maintaining the CPU allocation and RAM allocation to the each containers, and the permission is being done by the kernel capabilities. So those who are supposed to have a root access or non-root access will be done by the capabilities. But the question is, who is doing it? So kernel has so many namespaces, it can be duplicated, but who is doing it? So the tool which is doing it is Docker. Okay, so the tool will help you to interact with the kernel. Okay, so Docker is a tool. Okay, again I'm reminding you, Docker is a tool which will work with the namespaces, C groups and capabilities which is inbuilt in the kernel all the time to duplicate all the PID, net, MNT, user space, C groups and capabilities. This is the guy who will do that. So this Docker engine was written on the top of the Linux kernel, and they communicate with the Linux kernel to duplicate all the capabilities, all the namespaces, all the C groups virtually. So now each container thinks like they have got their own mounts, they have got their own process map, they have got their own networking, they have got their own permission, but actually it is done by the Docker engine. Okay, so now if I tell you what is a containers, so containers are nothing but a isolated user space. Again I'm reminding you, containers are nothing but a isolated user space with their own network, mounts, permission, capabilities and allocation of the CPU and RAM through the C groups with the help of the Linux kernel, and which is done by the Docker engine. Is that clear?
Yes. Srinivas has a question. Yeah, Srinivas, carry on.
No, I don't have any questions. I am saying that I am understood.
Okay, great. So now let's move on. So interesting thing is, if you look at the architecture, Docker works with the kernel. Okay, Docker works with the kernel. So yes, whenever you find a kernel, Docker can be used. Yes, you can find the Docker kernel on the laptop, on AWS instance, on Azure, on premises data center. So you can find the kernel everywhere. So basically, you can run the containers or Docker engine everywhere. Simple. So it's very simple. Now, who has developed the Docker? Docker was developed by Solomon Hykes. He was founded a company which is called Dot Cloud. Later on, it got renamed to Docker. Again, it is an open source product, and here Docker has been written in the Golang. One thing which I must tell you, in the recent last month, Solomon has resigned from the company which is called Docker. So now he's not associated with the company anymore. So that's one of the bad news. But still, he'll be known as like a founder or inventor for the one of the wonderful tool which you are learning now, right? So now, yes. So what is LXC? What is LXC? So let's understand this. LXC. So now it's like this. You have a kernel and you have a Docker engine. Docker engine is a libraries, is like written libraries, which will work on the kernel. But Docker engine need an interface. So to communicate with the kernels and evolve their capabilities. So they used to use it. There's one open source product which was called LXC, which is again open source, community driven, and stuff like that, to do the to sending the request and performing the things through the Linux kernel. So Docker engine was using the LXC libraries for the communication with the namespace use and capabilities of the Linux kernel. So what used to happen? LXC, they used to do the changes in the logic. So Docker engine also has to work on their software to support the changes in LXC. So that used to slow down the development of the Docker engine. So Docker engine was spending more time supporting LXC than evolving with and coming up with a new feature. So what they did, because Docker is open source, LXC is also open source, so they can copy the code as they wanted. So they copy the code of LXC and they put it in the Docker engine itself, and the name of the library, which they call it libcontainers. So now Docker engine has an engine plus libcontainer. So now LXC is not required anymore, and they can directly interact with the Linux kernel. So that is the inbuilt feature which you have right now with the Docker engine. Okay, so this is all about Docker. This is all about the containers technology. Now let me tell you, as you understand, Docker engine is very associated with the kernel, and you know that very well. Linux kernel is entirely different from the Windows kernel. So in a simple word, Linux C groups, namespaces, and capabilities are entirely different from the Windows C groups C groups and namespaces and capabilities. So in a simple word, you cannot run Windows app container on the Linux kernel because Docker engine will not be able to serve that purpose. Docker engine will not be able to give the network, mouse, permissions, CPU allocation to the Windows container. Same goes with that Linux Windows kernel also. So Windows kernel will not be able to run the Linux app. Okay, so this should be clear. Any confusion here?
No, Rajesh.
This is usually done by this Friday. I'll send you the CR.
Okay, so what is the containers? Containers are not for virtualization, and they are using the resources of the host machine. This is one of the limitation what we had, and we did yesterday discuss on this. Because of this limitation, we were learning the Kubernetes, right? So containers are not for the virtualization, and they are using the resources of the host machine. As a result, for now, container cannot run as is the Linux machine and stuff like that. So which we have discussed. Now, let's move on. So now, what I am going to tell you. How can we install and configure? So let's do that. You can install Docker Engine anywhere. You can install Docker Engine anywhere. So whenever you install Docker Engine, you will get two components. One component is being called as a Docker client, and another component which is being called as a Docker daemon. Sometimes is also being called as a Docker server and Docker client. So Docker server, Docker client, Docker server, or Docker client, Docker daemon, whichever you want to call it. Okay, so when you install Docker Engine, you will get the two applications. So now let's understand this. What is a Docker client? So Docker client is nothing but a place with is a tool where you write us commands. Okay, so Docker client will receive the commands, and the commands is received by the client will send to the server or daemon through the REST APIs. Server will perform that commands and responds back through the REST APIs on the client, and then you will come to know whatever the commands you have sent to the server, whether it got executed or not, and what is the status of it. Okay, so just remember, you have client, you have server, they interact each other through the REST APIs. Okay, you can install Docker anywhere. You can install in CentOS, you can install in RHEL, you can install in Windows, Ubuntu, anywhere. Okay, that is important. So one thing also I must tell you here, as you know, Docker Engine through the lib container interact with the kernel. Again, I'm repeating this line. Docker Engine through the lib container libraries, they interact with the kernel for the namespaces duplication, for the C groups, and for the capabilities. Remember, who can interact with the kernel? Only root. Okay, not a normal user can interact with the root kernel. So in a nutshell, Docker needs root permission to run the services of the containers. Without that, you will not be able to run it. So now you must be wondering, can I not run the Docker and then containers using the non-root users? Yes, you can do that, but what it has to be done, there is one group which is called Docker. If you look at this image, which is the second one from the bottom, now here Docker services is running as a root, but root is also is a part of the Docker group. Docker here, if you see that, is a group name, root is the username. So root is the part of the Docker group. So in a nutshell, anyone who is a part of the Docker group will be able to run the Docker engine. By default, root is the part of the Docker group, and he will be able to run it because he is the guy who has every access. But if you want to make the normal user should be able to run the Docker engine or the container, then you should add him as part of the Docker group. Okay, so that is the thing. Now this is the command. If you can see that it's the Linux command. Okay, you can do to add to the Docker group. So here is you see that npolitan, he is being added to the group called Docker. Okay, so now npolitan will be having access to the Docker. So simple word, Docker needs roots. Very simple. Now, as I said, Docker engine is having two things. One is a Docker client and Docker server. So is there any possibilities where you can run the Docker client at the different host and Docker daemon at the different host? Yes, that is the possibility. That is possible. How it can be done? So what you have to do, you have to run the Docker daemon not on the local host but to the IP address. Okay, so if you look at the first snippet of the command, if you look at this, I have stopped the Docker in the second line of the command, and after that I'm restarting the Docker, which should be listening on the host machine 2375 port number. Okay, the IP address of the host machine. So that way, if you start the Docker, then client also need to know where the Docker server is running. So in that case, the machine where you have a Docker client, you have to inform that your host machine is the particular IP address and the port number. So you see the second snippet of the command where we are setting up the Docker client is on some other host which has IP address and the port number. And then after that, you can run the commands. Yes, right now you don't have to do that, but if you want to do that in future, you can do that. Yes, you can run the Docker daemon and Docker client at the different hosts. That is possible. Okay, so now let's move on. So far, do you have any questions?
Yes, Rajesh. Actually, how Docker server authenticates Docker client? Any SSH keys kind of to be installed if it is on another machine? How it works?
Yeah. So here is like this. They interact through the SSH. So it has to, if it is in a different machine, you have to have SSH, public key, private key shared. So that way they work with it. But here, if you see that 2375 is the port number, so they send the communication through the TCP. Okay, so TCP is a protocol, authentication done by the SSH.
Okay, right.
Okay, now let's understand the last part of our discussion in order to understand the world of Docker. If you want to understand the Docker and if you want to learn about the Docker, you just need to know the 4 important components. So what is this component is all about? So you have a Docker engine. You need to know about the Docker images. You need to know about the Docker containers. You need to know about the Docker registries and repositories. So what is Docker engine, Docker images, Docker containers, Docker registry? And we will discuss this one. Let's move on and discuss something else. Here, look at this. This is the one image. Okay, this is one of the images which is pretty old. This is the images which represents the kind of the way we used to do the transportation of the goods, right? Goods at the through ships and ports and all stuff like that. So this is one of the oldest pic what you have right now, and this represents how we used to ship the goods early before many years ago. So look at this. Here you have a there's no standard different sort of different shapes and size of the goods. Look at this. All these 3 images, the goods are in a different size, different shape, different weight, and also mode of transportations are also very different. Look at this. Someone is handling manually, someone is being done through the crane with ropes, and some different kind of mode of the transferring the good from one place to another place. So this was the era what we had earlier. Same thing we do right now. Remember, 50 years or 70 years before, this was the kind of scenarios which we had in the port. Different shapes and size of the goods, and we used to have a different kind of cumbersome process to ship it. Same thing we are doing now. You are shipping the application from the development to test and test to the production. How much time you spend? How much time you spend? Do you spend a days or do you spend a weeks? What is the problem? So the problem is like here in a dev, the size are different of the applications. You have HTTP, which is small. You have Nginx, which is small, but you have a JBoss, which is large. A WebSphere, which is large. So what I'm trying to say, your packages, your applications are of the different shapes and size, different configuration, different environment, and when you want to ship it, that application from the dev to test, it takes days of time frame. When you want to put you want to migrate, if you want to ship your application from the test environment to the production, it takes a week of side time frame. But you know that if there's a problem in flipkart.com now, it has to be fixed now, within a few minutes or within a few hours. They cannot wait for the weeks, because the moment the duration of the release cycles will be converted into weeks, you will stop using Flipkart. You'll be migrating to Amazon.com, right? Or maybe let's say if your Ola is down for 5 minutes, you'll migrate to Uber, or maybe Uber is down for some time, you'll migrate to Ola. So it's very, very important in the age of cloud and in the age of internet-based services, the application has to be deployed, shipped in a very, very less span of time. Very important. So here in this picture, if you see that, we used to transport the goods and used to take a months of time frame to transport. Why? Because the goods were in a different shapes and size, different mode of the transportation and different things. Now we had the same challenges because we have a different kind of package, different shapes and size, different configuration required, and we have many other challenges. So it takes lots of time from the dev to reach out to the production. So what these guys did, what the shipping industry did, what the port around the globe they did, they created a standard. They created a standard. So now no matter what kind of goods, what shape of the goods you have, whether small or big, you have to keep it inside the container. They will not ship any goods without the containers. So containers is nothing but created a specification around the globe, So if you want to ship it the goods from one place to another place, you have to follow the containers. You have to keep inside the containers. Same thing what we did, we wanted to ship the application from the dev environment to the production. We converted into the containers. Yes, your app could be any shapes and size. You put it in the containers and you ship it. No problem. Okay, so you could ship the HTTPD same way as you could ship the JBoss or IES or anything else also. It could be any shape and size, I don't care, but it should be shipped from the dev environment to the production in no time. So we created a standard specification, and standard specification is known as Docker Engine. So Docker Engine is a platform which will help you to ship all the application from the one environment to another environment. So what shipping industry has done it? They have created standard across the world. All the shipping port will be following the same standard. All the trains, all the roads, all the trucks, all the cranes will be designed to support the specification of the containers. Don't you think so? So whole industry has got the revolution. So now you can imagine how much of transport we do. Remember China. China is getting the raw materials from the Africa, Australia, and India. They ship it back to their country. They produce the goods. They ship it back to the whole world. Still, it is cheaper. Same thing we have to do the applications also. We have to ship the application from the dev to QA and QA to the production. We can reduce the cycle from the weeks to the few minutes. So the product will be much cheaper. Your application development cost will be cheaper. That is what every organization wants to do that. They want to reduce the deployment cost. They want to reduce the release cycle. They want to improve the quality. So this standard process worldwide has created a revolution in a container. The same way Docker engine also has created a revolution in the shipping the app. So now Docker engine is a platform, just like this is a platform. Okay, the Docker engine is a platform, and this platform installed everywhere in the dev environment, in the QA environment, in the production environment, and you can run the ship the containers within a matter of few seconds. Okay, so now you can run these containers, same containers you can run in the laptop, same containers you can run in the data center. Shipping is so easy. Same containers you can run in the cloud also, with no time frame. So shipping has become so easy with the specification which was provided by the Docker engine. Do you understand this? Do you understand this?
Yes, Rajesh.
Okay, cool. So now so far we have been discussing about what is Docker. We try to understand what is containers. We also try to understand how container works. And then we also try to understand what is Docker engine. Docker engine is a platform for shipping the application, common platform. So we have to have a Docker engine everywhere installed, and that will provide a base platform of the shipping the application of any form, any size. Okay, now let's look at the Docker images. Docker images is nothing but a look at this image, kind of a file system. I'm saying file system. I'm not saying file. Okay, Docker images is a kind of file system. Look at this here, the first image, which represents the VM model. You have a hardware layer. On top of it, you have a hypervisor. On top of it, you have again hardware specification. That much for the each VM. You have a mouse, you have a CPU, you have a RAM, you have a network, and you have a ISO file. Four important things. That is ISO file is nothing but the operating system. If you go to the container model, what you have here, you have a server which is called Docker engine server, and top of that you have an intelligent file system. Which file system has PID, network, and file system, and top of that you have a Docker engine which manage the containers. So basically images is nothing but, again I'm reminding you, images is nothing but intelligent file system which has the network specification, file specification, process ID specification, which is been used by the Docker engine to run the multiple containers. So interesting thing is, one images you can convert to thousands of container. Again, one images it can be converted to thousands of container, whereas in the virtualization model, if you want to run the thousands app, you have to have 1,000 VMs. In a container world, if you want to add the 1,000 container, you just need a one image. An image will be common for all the container. Again, I'm reminding you, one image will be common for all the containers. In the other model, you have a number of app, you need to have a number of VMs. Okay, so this is important. So images are nothing but a kind of file system which contains your applications. You can run as many times you get the container. So we'll again come back and discuss more about the images. I don't want to confuse you, but for time being, you can consider images is nothing but a kind of ISO file. It's not correct statement, but to have your visualization in a proper perspective, ISO file, but Remember, in the virtual machine, if your ISO file is, if you want to have a 10 virtual machine, you have to load 10 times this virtual ISO file. But in the container technology, one ISO file, that means one Docker image, can be the base for the running the multiple container in a simple way, multiple app. Okay, that's important. Now, the question is, I just said, images is nothing but which contains the your application. So from where you can get the applications, sorry, images, from where you can get the images? So you can get the images from registries and repositories. Okay, so what is the registries and repositories? Images are nothing but a kind of file system which can be uploaded and shared across the repositories. For example, let's say you have a package which is like your package which is like war file or jar file. Where you keep it? You keep it in the Nexus or Artifactory. Let's say you have some package which is a public package. So where do you keep it? You store in the Yum or APT or NuGet, or maybe if you have a package which is based on the mobile, so where do you store it? You store in the Google Play. You have a package which is for the Apple, you store in the Apple Store. So similar way, you store the Docker images in registries and repositories. Okay, so we have a hub.docker.com, which is a public repository. Again, you can have your private repository also. I will talk about during the other demo. But for time being, registries are nothing but a repository where you can, from where you can download the images, okay, and store it also. Okay, so for time being, we'll be using the repository which is called hub.docker.com, and there we will find many images, many repositories. Okay, so now this is the one. So we have discussed right now what is a Docker engine. Docker engine is an engine, a platform which need to be installed. Docker engine manages your containers. Image is nothing but a kind of intelligent file system which contains your applications. The moment you run the images, again I'm saying, the moment you run the images, it become a container. And from where you can download the images? Registries and repo. Is that clear?
Yes, Rajesh. So we can make private repository also on hub.docker or anywhere, and we can have it. We can use it accordingly, company wise.
Yes. Yeah. So each of these topics will be deep diving into it slowly. So I'm not getting into the much detail right now, but again we will deep dive into the what is the images, what is the containers in detail, what is a repository, what are the kind of repository, or what are the kind of Docker engine also. So we'll deep dive into that slowly. Okay, so now I don't want to give you the more PPTs, presentations and all. Probably you get confused. Okay, so let me show you quick demo. Okay, so now I should give a quick demo before we wrap it up. As I said, if you want to be a geek in the Docker technology, you need to know a few things. Docker engine. You need to know Docker images, Docker repository, and Docker container. So Docker engine is nothing but a platform Docker images is nothing but app, because it's all about app. Docker repo is nothing but from where you download the images. So Docker hub.docker.com. Docker container is nothing but a running state of the images. Okay, any questions you have here?
No.
Any questions you have? slides?
No, Rajesh. No questions.
Good. Okay, great. So now let me give you the quick demo, because if I discuss too much, you will be lost. So you need a visualizations also. And for the visualizations, I need a machine. So as I said, Docker engine, you can run anywhere whenever you find a kernel. So let me run it in the AWS. Okay, so I go and get one virtual machines quickly. And here I'm going to grab one machine, Launch instance. I'll go for the RHEL 7.5. I'll go for the 4 GB RAM. One machine is sufficient for me. 10 GB is, I'll convert into 30 GB. Security, I have selected the one which I needed, and launch. And the keys I have selected which I have it. And here it is. So now I've got the one machine right now. And this is the IP address which you have. And now I'm going to log into this machine. So here I've got the keys here. Final.ppk. Open up console. Yes, ec2-user sudo-s. I'll make this because I've told you, because Docker needs root, so it's better to become a root and then do the things. You can also add the normal user to the group called Docker, which is not there, but you will get in this group created when the installation will be done. Now the question is, how can we install the Docker engine? And for that, I should go to my portal, and everyone should be aware of it. DevOpsSchools.com, tutorials, Docker, installations and configurations, and I'm going to install an CentOS, which is here. Click on it, and now I should first, if you have an older version, you should uninstall it. But I have no older version, so I have no need of the uninstallation. So I'm just running this command, which is there. And then after that, this repository where the Docker engine is there. Done. And then finally run this. Okay, so there's a problem. This package is not available because of the dependency solution. So let me check. Is the problem? So let me add skip broken. Now it's getting okay. This problem I can sort it out later, but let me try. If I have got this Docker installed, Docker is not installed, no problem. What I do, I will use probably the latest version has some dependency issues, which is not done properly. So let me redo the things before I try the old method. This is there, and I do not find any issues. This is already I've done. Let me. Here it says package Docker C, which is stable, error package C, SC Linux. Okay, so here is that SC Linux is needed. So this is the one error you get it. Now you have to install the SC Linux. Basically, you have to upgrade the SC Linux. So right now in this machine, SC Linux is older. So what to do? Yum update. You can do yum update and SC Linux will be upgraded. But for time being, I'm not interested in that because I know that yum update will take more than 10 minutes. So what I'm going to do right now, I am going to follow some different way. So let me do one thing. Let me follow the older Docker engine because it's 3 months older. So that will help me here. Up. And after that, installing the Docker engine, which is few months older. And here, this is also have an issue. Let me get a new instance quickly, or let me first kill that because folder is not having any such dependencies. Four, 1, 30. Quickly, I get a fresh machine because SC Linux is one of the thing which I will get only through update, and that is time taking stuff. So I want to avoid it. Here I got this IP address and let me log in. New session. I auth. Finally ppk. Open. Change the view so you can see it better. 16. Okay. Apply. Okay. Now restart session. Yes. ec2-user sudo-s. Now I am going to follow the older version. That way I will skip the update requirement. This is done. And installing the older one. The older one will work with the older Linux of SC Linux. So that's not a problem. And you see that installations went good so far, no problem. It's 17. So in the last one, it was demanding, I think, 2.9. Okay, so that was a little bit. Okay, now here enable the services and then clear the screen. Docker info is the first command. It's not there because you have not started the services. Start the services and Docker info. See that here you have how many images containers? 0, running 0, pause 0, stop 0, images 0. So now I said one line. It's all about application. About applications. So which application you want to run it? Decide. Jenkins. From where you're going to get it? You're going to get it from the hub.docker.com. The moment you run this image, you get container. That's all. Let's get the images. This application can be anything. So I'm going to give more introduction about the hub.docker.com later, but I just want to do the quick demo because I believe there's someone who has posted like there's a meeting at 9:30 at your location. So I do not like to interrupt that meeting. See that here you have a 1 lakh plus free apps. So I want the which image? Jenkins image. Here I go. Pull Jenkins. So now I get these images. Before that, we have how many images? None. So pull these images. And now you want to run this images and become a container. So one image I will add in the detached mode. I'll explain you all this thing, but I'll give you this visualization right now. I'm not going to explain each and everything right now. It's just I want to give you a visualization. How can you get the containers immediately running? The container will contain your app.
Rajesh, sorry to interrupt, but we need to wrap up this in another 5 minutes. We have a scrum. I have a scrum,
Yes.
and I have a couple of more meetings. And one more important point. Can we make it to from 9 to 10:30? Means from 7:30 to 9 instead of 9:30 at a 1.5 hour session, because we have an important every morning we have like meetings, and we have a delivery going on for a couple of projects. So
Can you do one thing? Just a second. Give me this quick visualization. Just a second. Let me run it. Okay. So here I run it. One app from one image. So now let me show you this. This is the IP address, the port number 8080. Here you got this application running. Now Link is running. And now you want to run one more app. Let's quickly do this. One, just change it. I'm going to explain everything in detail, but just a visualization right now. Okay, let's see that. This is one app. Within a second, I could get another app running. Within a second. Look at this, so fast. So yeah, again, I'm going to come back on this topic, discussing more about this in much of detail. But yes, this is what we have. So today, what we have understood, what is Docker? Why Docker? These two questions we have understand. Then tomorrow we will understand how Docker. That means how can we use the Docker to save the cost, maximize the utilization of the hardware and other things. Okay, any questions?
No, Rajesh, we're good.
Okay, so what we will do, let's have a discussion about the rescheduling the timing over the WhatsApp. So that way, I think we'll be not, coming in between your meetings. Okay.
No, Rajesh, is that okay, Shomik?
yeah.
Okay, yeah.
Sure. Okay, guys. See you tomorrow. Have a nice evening. Bye.
Okay.